Morning, welcome to
KidMath number 71.
KidMath number 71. So this was a very interesting problem you ran across just doing some factoring practice on Khan Academy. It was the section about factoring quadratics, right?
Mm-hmm.
And this was pretty much a showstopper, wasn't it?
Yeah.
Why?
Because it's a cubic.
It's a cubic. A cubic. Wow! But it gave us a chance to have a really good talk about factoring, right?
Yeah.
So it's interesting. I wasn't sure why they would put a cubic in the quadratic section, but it turned out to be pretty interesting. So let's talk about it.
Alright.
What's the idea when you're factoring?
Well, you want to reduce it into like x minus something squared times. Let's not use.
Why x minus something squared?
Wait, no, x minus something times x minus. Let's just do x minus a times x minus b.
Yeah. So you're trying to, for quadratics, you're trying to get it into x minus a times x minus b, and sometimes you might have a constant out in front, like 2 or 3, whatever it is. Okay. Now with a cubic, it's just going to have one more factor, x minus c. And these are the roots of the polynomial, right?
Yes.
So this, if plugging in x equals a would make the polynomial be 0. Plugging in x equals b would make the polynomial be 0. Okay? Let's see if we can apply these ideas here and just make some sense out of this cubic. So, what, if anything, do you notice you can factor out?
A negative 2.
Okay, so the first thing is to pull out that constant minus 2.
Yeah, just get rid of the constant.
So it's minus 2 times what?
X cubed.
X cubed.
Minus 12x squared.
Minus 12x squared.
Plus 20x.
X cubed minus 12x squared plus 20x. Awesome. Okay. What we have inside these parentheses is slightly less complicated up here because we took a 2 out actually, or minus 2 out.
But you can factor in an x.
Each term has an x in it as well. So now we can factor out an x. Minus 2 times x squared minus 12x plus 20. Probably should have let you say that, but oh well. So, and what does it mean that when we factor out an x?
Well, we're basically dividing by x in here, and then we're multiplying by x.
Okay, yeah, that's one way to think about what you're doing, but what does it mean for this polynomial that you can factor out an x?
Well, it just means the powers of x get lowered one term.
That's true also. Does it mean any other consequences? What does it mean that we can factor an x out?
All the terms have an x in them.
Yeah. Yeah, we'll come back to it later on. Okay, now we have a quadratic though here.
And this is, it's x, it would be x minus 2 squared, x minus 2 times x plus 10. No, x minus 10, I got it.
Okay. So now we're able to factor this, x minus 2 times x minus 10. Let's just check that 2 makes this quadratic part be 0. 4 minus 24 plus 20.
Yeah, and if this is 0, then this is going to be 0 here, because minus 2 and times anything, minus 2 times 0 is going to be 0. So.
Okay, so what are the roots of our original cubic equation?
Well, it's minus 2 times x times these.
Right, so what are the values of x that make this polynomial equal to 0? Which x's make this expression that factors into this equal to 0? What values of x make this equal to 0?
Well, there's 0.
X equals 0.
And then there's our 2.
X equals 2. And x equals 10. So we have 3 roots. So what did it mean that we could factor an x out? What did that tell us?
Well, this is the same as x minus 0.
So the same as x minus 0, so it told us what?
It told us a root.
Was?
0.
0. When you can factor an x out, it tells you that x equals 0 is a root. And you can see right away, when x equals 0, this term 0, that term 0, and that term 0. So being able to factor an x out means one of the roots is 0. And now when we got it to a quadratic that we knew how to factor, we knew the other roots. We found them, x equals 2 and x equals 10. Okay? Pretty cool.
Yeah.
Pretty cool. So what seemed like a very difficult problem, factoring a cubic, turned out to not be that hard, actually. First we factored out the minus 2, then we factored out the x, then we were left with a quadratic that we knew how to factor. Then we got all the roots. All right?
Yep.
Good job, sweetie pie. Good job.